This video is about the derivatives of the sine and cosine function, and I'm going to show you where the history or how we came up with the derivatives, and then I'm going to show you the rules, and then we're going to do a few practice problems. There'll be another video for the other four trig functions. Before we talk about the derivatives of sine and cosine, I just want to let you know that trigonometric functions yield trig derivatives. So when we go to look at this, I'm just letting you know every single trig function is going to have a trig derivative of some sort, all right? So in order for us to go through this, I plotted here a picture of the sine curve. And if I were to ask you to, and we've done this before, sketch a graph of the derivative, first we would put the f prime bar, which is basically a timeline, and a number line. And you know that on the number line here that what we're going to do is look at where the derivative would cross the x-axis. So right here the slope is 0. So we know it's going to cross the x-axis there. Then we come down and make a line. The derivative is 0 here, so we know it's going to cross the x-axis there. So we're going to draw a line. The slope is 0 here, so the derivative is going to cross the x-axis here, and I'm going to do it over here too. All right, so now what we do is we look at what our function is doing. Now you know that if your function is increasing from here to here, that means my slopes are positive. If my function decreases, my slopes are negative. So it increases from here to here, so I got positives here, negatives here, and so on and so forth. Now remember, this is telling us our function is increasing, decreasing, increasing, decreasing. But if you were to graph the derivative, if it's positive, you're going to graph above the x-axis, and if it's negative, you're going to do below. And since we know that trig functions yield trig derivatives, it's going to be another trig function. So let's kind of look at what this would look like. So above, below, above, below, above. All right? And if we look at this new black line that I've done, it looks like, if I was thinking of a trig function, and we'll just look from here 0 to 2 pi, it looks like the cosine curve. And that is what the derivative of sine is. So right here, f prime of x is going to be the cosine of x. So the derivative of sine is cosine. Now let's look at the derivative of cosine. We're going to do the same method. We're going to do our f prime bar, which is just a number line, and we're going to sketch the derivative using if it's increasing or decreasing. So right here the slope is 0, so I know it's going to cross here. The slope is 0 here, it's going to cross here. Draw our line. And I continue on. All right. Now, our function from this point to this point is decreasing. It's increasing from this point to this point, decreasing here, and increasing here. Now, again, remember what I said, that we're going to yield another trig function. So we're going to go below here. So it's going to be right here. It starts kind of like this. So let me see how we're going to do this. This is above. Let's do this here above. Oops, sorry. Let's erase that. Let's undo that. So here it's going to kind of cross here. It's going to be below. Okay. Then it's going to kind of come above, below, above. All right. So it's kind of wiggly. But let's look from here to here, from 0 to 2 pi. It looks like it starts at the midline, and sine starts at midline, but it doesn't come up and come down. It comes down first. So the derivative of cosine is going to be negative sine, because it's the sine curve reflected in the x-axis. So below here, now that we know where they come from, we can say if our function is sine x, the derivative is cosine of x. All right, and this should be on your derivative card. And again, the derivative of the cosine of x is negative sine. Now I do want to show you something really cool here in the bottom, and we'll be using this a lot later, but here's the sine of x. Okay, so we're going to do it like this. We're going to make like a little box. If I take the derivative of sine x, make an arrow here, it's cosine x, because we just found out. The derivative of cosine x we just found out to be negative sine x. Now watch this. If I take the derivative of negative sine x, well, the derivative of sine x is cosine x, so this will be negative cosine x. And if I take the derivative of negative cosine x, it's negative sine x, and it's negative negative sine, so it turns out to be sine. So this just continues to repeat and repeat. So here's the first derivative, second derivative, third derivative, and it keeps going around and around. Okay? So that's interesting. You'll be using that later on. Okay, the next page. So this page, this video is going to be a little bit short, but I wanted to do about 6 examples with you, and then this video will be done, and then I'm going to do another video with the rest of the trig derivatives. So we're going to do a prime of x, and we're going to remember this derivative of sine is cosine, so if y equals sine x, you know that y prime is going to be cosine x. We'll just put this up here. If you had y is cosine x, the derivative is going to be negative sine x. And the other thing is, I don't want you to forget that I always tell you you should know this derivative sine squared x plus, not derivative, but this property of this identity, that sine squared x plus cosine squared x equals 1. And lots of times I look for that to see if I can replace that with a 1. And we'll see a couple of examples. So when I do a prime of x here, this is the power rule, so this is 2x. The derivative of sine is cosine, but there's a negative there, so this would be minus the cosine of x. And if you want to shut this video off and try these and then turn it back on, I'll go through each one with you. That's fine. The derivative of this, well, before I start, I look at it and I look like I have a product here. So here's my f and g. So I know I've got to use the product rule, so I have f prime g plus f g prime is the product rule. So let's figure out what our f and our g's are. So f is the sine of x. F prime we now know is the cosine of x. G is the cosine of x. And g prime is going to be negative sine of x. So if you do your work here on the side, it makes it so much simpler when we plug it in. So I have b prime of x equals, I have f prime g. So when I do f prime times g, I have cosine x times cosine x. So we're going to write that as cosine squared x. And we put the squared right here, but it's really cosine x, the quantity squared. And then I've got to do plus f g prime, and f and g prime, when I do sine times a negative sign, it's a positive, but this turns negative minus sine squared x. And there's really nothing I can do to it, so there's that derivative. Now let's look at 3 and 4. These are a little bit longer, and when I look at them both, I see that they're fractions, so these are quotients. So they're f and g's. So I guess for this one I'm going to set it all up. So I have f is cosine of x. F prime is going to be negative sine x. G is 1 minus sine x. G prime, the derivative of 1 is 0, and the derivative of sine is cosine, but that negative's there, so it's going to be negative cosine x. Now recall that you know the quotient rule is, if you did the quotient rule, y equals f over g. Y prime is f prime g minus f g prime all over g squared. Okay? So we're going to basically plug those into that quotient rule. So I have c prime of x is going to be f prime g. So I have negative sine x, excuse me, times 1 minus sine x. And then I got minus fg prime, and fg prime is cosine times a negative cosine, so this actually turns positive cosine squared x all over g squared, which is 1 minus sine x squared. So c prime of x. So we've actually done the derivative. Now let's see if we can simplify this. So I'm going to multiply this times this and see if I can get some neat things going on here. So I have negative sine x plus sine squared x plus cosine squared x all over 1 minus sine x squared. Now here's the cool thing. I see this, sine squared x plus cosine squared x. So those two right there, because of the identity that we know, the trig identity, I know that's 1. So I can really write the numerator this way. I love it when this happens. 1 minus sine x all over 1 minus, excuse me, sine x squared. Now this makes it easier for you. Put parentheses around this. I say, oh, I can cancel this out. I end up with 1 over 1 minus sine x. Oh, I love it when that happens. That's a nice derivative. Okay, I have another quotient rule. I'm not going to rewrite this up here. I hope you know this, but we'll just leave it there for now. So let's set it up so we can put it in that formula. So I have f is sine x plus cosine x. F prime is going to be, well, the derivative of sine x is cosine x. Derivative of cosine is negative sine. G is going to be cosine x. G prime is just going to be negative sine x. All right, so I'm going to go through and do each piece here. So I'm going to do d prime of x. And we're going to do f prime g. So I got f prime g. So I'm going to put the g kind of in front. So I've got cosine x times cosine x minus sine x. I'm sorry. And then I'm going to subtract f g prime, but this is already negative here. So I'm going to go really slow here and do minus, and then I'm going to do this. So we'll go fast slowly. Sine x times sine x plus cosine x. Okay, all over g squared. Okay. Now, once you do the derivative, which is nice, part of it is trying to get it so it looks a little nicer. So we're going to do the distributive property and all sorts of stuff here. So I've got cosine squared x here minus sine x cosine x. Okay. Now, this is a negative. I'm going to leave it here for now, so I'm going to go fast slowly. We'll do everything in here. So I have a negative sine squared x here. And then I have a minus sine x cosine x all over cosine squared x. So when I do d prime of x here, if you'll notice, this is a negative. So this is going to turn signs right here. So let me highlight this. This is going to turn to a positive, and so is this going to turn to a positive because of this negative sign. So if this turns to a positive and this is a negative, these actually are canceled out. So let's look at the numerator. I have cosine squared x, and that negative sine squared x turned positive all over cosine squared x. And again, I'm all excited because I found this again, which is our identity, which I know is a 1. So I can write it as 1 over cosine squared x. And sometimes you'll look at the answers and you'll see that's not the answer. You might see it that way, or you might be seeing it called secant squared x. Either one of those would be okay. So that was kind of fun. Let's try a couple more. And then this video will be done. So this one right here, we've got two quotients. So we're going to do f and g for this one, and then f and g for this one too. So we're going to have to set these all up. So the first fraction, and we're going to use the same rule, f is cosine of x. F prime is going to be negative sine of x. G is x, and g prime is going to be 1. Let's look at the second fraction. I got f is going to equal x, f prime is going to be 1, g is the sine of x, and g prime is going to be the cosine of x. So let's set them up. We've got two quotients here. We'll do them both side by side here. So e prime of x is going to equal f prime g, so I have a negative x sine x, I just put it in the front, minus fg prime, so we're going to have a minus cosine x, all over g squared. That's our first derivative. Plus f prime g, so I have a sine x, minus fg prime x cosine x, all over g squared. Okay? Now, it's too good to be true that that would be the answer. I want you to find a common denominator. So we're going to do e prime of x. And then when I find the common denominator of this big long thing, you know the common denominator is going to be x squared sine squared x. So when I do that, okay, I'm multiplying this whole thing here by sine squared x. So I basically have sine squared x times a negative x sine x minus cosine x. And here I'm multiplying this whole thing by x squared, so I can use the common denominator. Okay, now let's see what we end up with if we can make this look a little simpler. So this right here, I'm going to multiply this by this. So I have negative x sine cubed x minus sine squared x cosine x plus x squared sine x minus x cubed cosine x. And this is all going to be over x squared sine squared x. And then I look at it, see, is there anything I can factor out of all of them? And I can factor an x squared out of these two, but then I'd be back where I was. It's not going to really simplify, and I can't really cancel anything, but I've tried, so we're just going to leave it the way it is, because there's really nothing you can cancel or simplify to make it look nicer. All right? Last one here. Now this one is the one that's not a quotient rule. I still have f and g's, but this is my product rule. So you know y prime is going to be f prime g plus fg prime. So f prime of x is going to be, all right, let's do our f and g's. F is x squared. F prime is going to be 2x. G is going to be cosine x. G prime is going to be negative sine x. So let me move this down a little bit because I did all that on the side. So I have f prime of x is going to be f prime g, so it's going to be 2x cosine x plus fg prime, and it turns to a minus. And if you can do things in factored form or simplify, I prefer it. This is the derivative, but let's factor out what we have in common, and we can take out the x. So it's x times 2 cosine x minus x sine x. Okay, well that's the end of this video on the derivatives of the sine and cosine derivatives.